Hey everybody, good morning. Welcome. So to give a quick update for those that are here, maybe you didn't catch yesterday, and those that might be watching later, what we're doing today and what we started doing yesterday. Let me just go ahead and pull up. Let's see. So that's interesting. So what we've started doing is we have basic collisions going, a lot of the player input states, but what I'm going to be working on and what I started working on yesterday was an entity component system to where we can start abstracting some of this stuff and make it a little bit more scalable for all the stuff that we're going to have to add. Why is it main.cpp, not pure C? Because I'm using IMGUI. And IMGUI has a C port, but I've never gotten it to work correctly or well. So I don't really mess with it. But Gunslinger compiles for C++, so you can do that, and everything that I still write everything in C. So I don't use any C++ standard library stuff or any of that stuff. So what we got started yesterday was, so if we actually so we've got some basic ECS stuff that we're doing. And we'll have, let's see, for a component, we're going to do some basic aggregation to have a little bit of inheritance. You can do that in C. It's very easy. So we're going to have a component state that lets us know whether or not a component is active, inactive, etc. Anything else that we might want to have. That's probably the only two states that we'll actually need. And then every component will inherit from that. So it'll aggregate that to the top. And for now, we're going to have a transform component and a sprite component. And then we're going to have what are defined as entity groups. And I've gotten this idea from Ryan Fleury. I like it quite a lot, actually, because what it does is that it takes component data that normally would be in either separate groups or it would be bundled together by component type. Instead, what it does is it bundles all that data together by an entity type where it's actually going to be used. So that you can update groups of entities. You can update all their component data in one shot, which is good. So the entity group will have a base type of this entity group T, and it's going to keep this information. We care about count for the entities that are in that group, a max count if we set something like that, and then a free ID as well will be used. Here's some of the declarations that we're going to use for all this kind of stuff, and it's templated using macros. How we're actually going to call into this by passing groups, and then the template type. And then here we're actually defining one of those groups, right? So we're going to start working on bullets. So we'll define a type of entity group, which is a bullet. We have a base, again, is going to be this entity group. And then here's the component data that we're actually interested in, right? So we have transform components and sprite components. And again, like I said, it's a large array of all this component data. Here's the update. We'll actually start filling this out later. We don't really have much for that right now. Right now, we're just grabbing from the group the actual data for all this kind of stuff. And then this is our setup, right? So what we could do actually is instead of doing this being a pointer, it could be something like this. So they're just flat arrays. We could do that. which we might move towards that to avoid the malloc. Shutdown, etc., etc., etc. Now, one thing we do need to do, and this all works fine, is we need to, let's see, actually start working on adding and removing let's see, adding and removing entities from the group. So that's what I'm gonna start working on now. Let's see, for some reason this is acting strange. Oh, that's why. That should be fine, yeah. I also went through right after the stream yesterday and found, see, like a bullet and a shot. Go into here. So I found these, so we'll use these later. So this will be our bullet that we'll use for like our straight bullet, and this will be whenever you shoot, we'll place that at the end of the gun. We're gonna have to do like find like an attachment point and put that into data somewhere, but we can find that. I have no idea why this is showing up for the background data though. That's strange. So I need to look at that real quick. Yeah, earlier today, just $291, $255. Yeah, this should be right. I don't know why that's popping up. Must be something else that I'm adding in. I'll figure that out later. It's not really important. Because I want to figure out how we can add in this entity data. Don't need that. It's fine. Okay. So we are going to need to find, so we have a free ID for the group. We have a max count that we could possibly have for the array. Then we have a current count, which is just our count. So using that, we'll be able to find what the free ID is for our entity that we're actually going to create, and then we'll return that back to the user. We'll do the exact same thing for the remove. But we won't return. Instead, we're passing in the ID. So for this one, we remove the ID and then set our free ID. And actually for the free ID, what we might do is make that, instead of a U32, we'll make that S32. Well, we could define that. Which I think, no, it's in types. AVMA, Uniday. Entity group invalid. Okay. Okay, so we have an invalid entity ID. Which we actually might want to make like a simple macro to set this up, because I guarantee you, as we're making entity group default. I didn't understand what you asked me. I don't remember what I asked you. If I asked you anything. So for the initialization for this, what we'll do is bullets base is the entity group default. Then we can get rid of this, but we do want to set that. Again, this is just so that I can have that free ID set by default. I won't forget that later on when we're defining new entity groups. So we have our bullets here. We have our free ID. We don't need to set the max count, but we're going to use that. So let's see. Find free ID. And the way we're going to do this is that we're actually just going to loop through, because we know for any entity, that's the kind of the beauty of these entity groups, is that we know for any given entity, if we look at the bullet, right, the amount of transforms is going to be the same as the amount of sprites. It has to be a one-to-one match, because each entity is made up by the sum of its parts, meaning that each entity will be defined implicitly by the transforms it has. So you can think of a bullet entity as being implicitly defined by something that has a transform component and a sprite component, and that's it. And what that means is that it has to have those things. It has to have those qualities in order to qualify as being a bullet. So that means you only have to iterate through one of the arrays, to find out whether or not you have a free ID, whether or not that entity is alive or not, etc. So there is one thing that's going to be kind of unfortunate about this, which is that as we're moving around, so a couple things, being able to stop moving, well, try to avoid having gaps in our data, I guess is what I'm trying to say, right? So if we have something where we have let's say this is our array, right, of fully compacted array full of data, right? And so we're iterating through this in an update. This is the best representation for our data, is to have it like this, where there's no gaps in the data. So we'll just iterate from, you know, the start to the end, and then that's it. Now let's say the user comes back and let's say a bullet hit something. We're going to delete that bullet from memory. So we're going to say that one got hit, so we're going to fill it. Now when we come back to the update, we have a necessary gap in our data. What we could do is whenever we have that gap, as long as we're careful with how we do this, we could move the end of the array to that, okay? So now we still have a fully compacted array. We can iterate through that, and then we mark this as like our end. Now, the only issue with this is that if we have IDs that we're giving out to a user, which is what we're going to do here, we've just invalidated this ID. So there's a couple ways we could do this. We could actually use a slot array. So the slot array is going to be 2 arrays instead of 1. But what happens is it gives you back a handle. And you use that handle to do a double indirection into the actual data. And it's really fast. It's not much slower at all to be able to do 2 array lookups as opposed to 1. It's not like you're searching through a linear list or what am I thinking of? Like a linked list. Jeez, it's not like you're searching through a linked list like you would in certain hash map declarations. You're just looking through another array in order to get the handle, or in order to get the actual index into the array for the data that you're wanting using the handle that's given. So in this instance, when we do this and we move these things around, so we remove something from the slot array, this data will still remain compacted, but our handles will still line up correctly. So this might actually be the way we go. This is the reason I use slot arrays, and it'll kind of solve this problem. So, and also the beauty of this is we don't have to find a free ID. We just insert into the slot array, and it does that in the back for us. So I'm considering doing that. So let's just do that. Now to do that, you have to do a couple things. We have to declare a slot array for our type. For those of you that might be using Gunslinger for anything, slot arrays are in the container header file. So this is all of the information that you can get from that. There's also a slot map, which uses a hash map in the back end in order to, instead of using U32s or UN32s as the handles, what it does is that you actually have another indirection map in order to read into a slot array. So you can pass in any kind of data that you want as the key, and then that gives you back the index into the slot array. But you can still, the beauty of it is, again, it keeps the data compact. So we'll declare these two. So we'll have these two slot arrays. And then we're actually not going to iterate this way. We don't necessarily need to keep the count, but we'll do this in a second. So I'll go ahead and just get rid of this. These we do not need to do. What we'll do is declare a new slot array. And down here, I think that's all I need. And good to go. Cool. So we don't need to find a free ID. We actually don't even care about that, but we'll keep that for other groups should they want to use that. We don't necessarily even need this bullets max. We're not going to be using that. We're going to keep, because again, there's going to be a dynamic array. Don't care about a max count. Don't even care about a current count. All we're going to do is whenever you're adding a new bullet, we are going to get a handle to the slot array. So do we even want to necessarily put back particular information? Because we want to create a new bullet, and the bullet itself should have some information, right? So this is what I was thinking about these. Where is it? So this add declaration, we actually might want to do just data that we want to pass in, just random data. And we'll use this as like initialization data for the entity. So we can actually call this just entity data, right? And let's just say that there's particular bullet data that we're actually interested in. So maybe there's a how am I going to do this? So I don't know if it necessarily wants to be component data. Because when you shoot a bullet, you want to know the velocity that's going, right? So you want to know its direction and speed. So you kind of want like a, I mean, maybe we should make a physics component, and that physics component should be separate from this. So the transform component is just a transform, and then we have I mean, geez, we can actually call it like a rigid body component. Immortal says, John, I don't know if you're aware, but on the Handmade Discord server, there's a streams channel where people announce their streams. I wasn't aware of that. I usually don't check into the Handmade channel that often, so that's good to know, though. I'm also terrible at shilling myself. I am not a natural salesman by any means. Something I'm working on. So for the rigid body component, again, it's 2D, so whatever. We need a velocity, so we'll actually do a velocity vector. We'll keep our AABBs in here. It's our bounding box. And then that should really be it. And then for bullets, then we'll do the same thing down here. Okie dokie. And then for freeing it. All right. Cool. And then again, when we're creating, we probably want to pass in some kind of entity data, and then we'll create a new transform. So let's do bullet I don't know what to call this. Just bullet data, whatever. So let's see. Which again, we could have a transform component in here. We'll just put all of our component data that we care about. Although this might not be necessary because it doesn't really matter. Probably don't even necessarily need this. We just need like a velocity. So what do we actually care about? All right, we care about the position, we care about the velocity, because the bullets themselves are going to be, let's just do that for now. So we care about the position that we're shooting the bullet from, where it's going to start, and we care about the velocity that it's going to be going in the update. Everything else should be pretty statically defined because we know what a bullet's going to be in terms of its sprite that it's using, its atlas. Its rigid body is going to be the same because we know the size it should be. Yeah, okay. The scale should be the same. So this stuff should be kind of how we expect it. So the way this is going to work is whenever we declare a new bullet, we pass it in. And we're going to cast this to bullet data. There we go. And now what we're going to do is create a new, actually we have the group. Pretty sure that's correct. So we have an invalid handle. We're going to return the handle to the user. And the way this is going to work is it should be the same handle for all of these because again, you're adding and removing from one particular group of data. There's another way you could do this is you keep a, and this is how, if you guys follow the machinery, they actually keep for their engine components just a huge array of data, right? So you'd have void pointer, group data is, you know, actually it's all this, right? So it's all your components times, you know, max amount or something like that. So they would do something like this. So it's this big interleaved group of data, and then all they would do is just store pointers to particular areas of that data. And that's good for keeping down the number of disparate places in memory where your actual allocated data is. It's just one big block of memory. and then they just have pointers into particular areas of that memory that's interleaved, and then they can update it that way. I don't really care to do that right now. But in our case, we know, again, that number of transforms is the number of sprites is the number of rigid bodies, because that's the number of entities that we have. So all we're going to do is push back a new transform component, a new sprite component, a new rigid body component, and then that implicitly defines a new entity for us. So we're going to have to create these things. Okay, now we need to init these. Okay, and then let's look at a sprite component. So the sprite component has, again, a texture atlas. It has a UV. So we need to be able to grab the get the asset manager for this. Shit. Don't really care about the UV. We do need the atlas though. So it's just passing the texture that we'll need. We'll add that into the bullet data, because I don't want to be passing around this asset manager if I don't need to. For this UV, the UVs for this, let's see. It's 3131. 3636. Okay. Position's good, or scale's good for that. Should be a 1, 1, I think. Should be. Then we have a rigid body component. So we need to define this. I'm not exactly sure how we're going to do that. Not yet, anyway. So we have all of our data for the components. So now what we need to do is just pass all this into our entity group. Slot array insert. Don't have to do this, by the way. You could just do the last one. capture the last one, and then we return that back to the user. This all should compile unless I mess something up. Bullets max undeclared. Yeah, so don't really care about this. Don't care. Okay. So we're not adding anything right now. So what we can do is start pushing back. Now again, we want to be able to remove as well. Good thing with slot array, I believe I have this. So yeah, you can erase a handle. So you pass in an ID for the entity that you're actually interested in. We don't care about setting a free ID for this. But we'll erase. Which I believe is just ID. Yep. All right. Hey, GL Dev. So let's go ahead and, so we're not well, we are initializing this. So that's good, right? If we go down to the game context where we actually, yeah, so we initialize our bullets. So perfect. Let's actually add in a bullet. So we'll just do this in here. So we have bullet data. What am I doing? Yeah, so passing in Atlas. So we'll actually grab that from the asset manager. And this is background elements, right? Yep, that's right. Okay. Position for this, we'll just do it at, I don't know, 5.5. Let's just do it at the origin. But maybe a little up, so we'll do 1. And then the velocity. Okay. So this is our bullet data, and then what we're gonna do is call this entity group add for the bullet type. Pass in the bullets, and then we pass in our bullet data so that we can use that to construct our bullet. And let's see if this compiles. AM's undeclared. Yeah, because it's context. Function does not take 1 argument. Entity group add. Down here. So we've added a bullet. You can't see it. So we're not doing anything with it. We're not even drawing it. But it should be in data, and we can probably verify that if we come down here and we go into our debug info, and let's do something for bullets. Let's just do bullets. We'll do the full game context later. Okay, so we want to actually, what's with the ellipsis? That's actually how you do variadic arguments for macros. So these are all macros to do templated stuff, basically. So it's just generating code. That's how you do it in C. This is basically what C++ does for you guys. So people that say, you know, you can't do certain things in C that you can do in C++, it's nonsense. So it's basically just a templated argument for defining particular function declarations with certain signatures. So for all this is all the stuff that I'm interested in for a particular entity group to have, right? So this would be the equivalent of if I'm in C++, something like this, right? Basically that. Are those generic C11 specific? No, this is all C99 is the highest that I go. I don't do C11 just because it's not supported. C99 has only certain kind of support for MSVC, so there's a lot of C99 stuff that I don't even use. So I guess it's more correct to say that I stick pretty strictly to C89. But no, this is all just basic macro stuff. Yeah. But this basically just means I'm just going to fill this out with whatever I want. And then in order for the compiler to be able to replace all of this, it's going to look for this tag and just drop that in. So it's really simple, right? So this function declaration is going to take this type name. It's going to actually write that type name out as a string, which is what these two pound signs mean. So whenever this gets evaluated by the compiler or the pre-compiler, it's not even the compiler, it's going to basically, this is what it's going to evaluate to. So like for the bullet, it'll look like this. And then the arguments that I'm passing in is actually this function declaration. So if you go down to where I'm actually declaring this, right? So all of this is what falls underneath that ellipsis. So pretty straightforward. And I just do that way I can have this and then be able to easily declare it, like, you know, like I'm doing here. But let's go back to, what time is it? All right, pretty good. Let's go back to the IMGUI. So do UI, and now let's. So we want to iterate through the bullets. I actually have a way to do this. So nope. So we have iterators that we can actually use for these. So we're going to define, no, let's just do for oh. So we're not even iterating through that. We have, so entity group, periodic macros are more readable than temp. I think they are. I can get through the compiler errors certainly a lot faster. But some people don't like them, you know, that's fine. Dirty Matt, awesome, thanks for explaining that. Yeah, of course, that is what I'm here for. So entity group, bullet. So we're gonna grab our bullets from our game context. And again, this is from the context as an entity set. And I stole this directly from Ryan Fleury. So again, thanks, shout out to him. This idea anyway, for how to structure this. So it's getting kind of gnarly. I'm gonna have to start splitting this up pretty soon, just for readability. So we have the game context. That game context has an entity set. And inside of that entity set, it's gonna have these different entity groups, right? So later on, we're gonna have things like Grenadier, you know, or entity group Rifleman, you know, stuff like that. But for now, we have just these bullets. And so we're gonna grab the entities, and then we're gonna grab the bullets from that. And just so I could find this faster. So bullets is the game context. And I'll grab the address of that. So we're going to create an iterator for our slot array. So let's just do just the transform components. It would be nice to be able to group entities. I'll think about this later, but for now we'll just iterate through the transform components. We'll just do that. So we have a iterator new, and you pass in the slot array that you're interested in. So we're going to fill this out. And this is basically, it's just a simple for loop, right? So we define an iterator, and then we're going to advance the iterator. Or actually, we're going to give an addition, function that we're actually interested in, which is the iterator is valid. So we're only going to continue to advance if we have a valid iterator. And again, we pass in slot array we're interested in, and we pass in the iterator. And then we iterate the iterator. Make sure that compiles. Sometimes I forget bullet T iter. Right, because it's not that, it's a transform component. It's not slot array advanced, slot array iter. All right, so we're now iterating through open this up. Shit. Let's see. Where did I mess up here? Tell you what, let me see. Make sure that we actually have bullets. Okay, so I think, did I not? See, this all seems fine. We should be adding one into. Oh, I'm never calling this. Never calling it. So, geez. So let's call it just down here for now. Now it's going to crash, I think. Well, maybe not. Okay. So we weren't ever initializing that, so none of that data was getting set. All right, so we do have. So now if we go down to our debug UI, debug this should work now. It would not spam that print. Now if I print these out. Okay, so we are iterating through. We're not grabbing any of the data, but we are iterating through and it's not crashing, so that is working correctly. We're not spinning forever. So now we can grab individual iterator data and then we can debug print that. So the way that we grab iterator data, the way this actually works is that it's the iterator itself is storing a pointer. Why don't you use Vim? I've just used Sublime Text. I mean, I've got the color set up the way I want. I can get around fast enough in it. It's not really worth it to me to jump over to something else. I am very slow to adopt new things. I am very conservative in that way. So for the iterator, let's see if we actually look at the iterator declaration. Where is it? Where are you at? Here we are. So it stores a pointer to the actual data itself, and then it stores an index into that. Okay. And so all this iterator is doing is it's going through and it's looking at the data and it's like, is this data valid? Is it currently accessible? If it is, then it caches that pointer and then it returns the iterator back to the user. So then what that means is all we have to do is that transform component xform is we just have to we literally just have to grab the data because it's just pointing to it. That should work. Right, it's not that, it's IT and it's a, okay. So we grab that data and then we can print it to the screen. So let's just do this exact same thing. Transform position, yeah, so we'll just do that's right, 'cause it's slider float. Oh, it needs to be a right. So now we should have a single bullet in here, and again it's at 0, 1. And we're actually able to manipulate that data, by the way. But again, we're not seeing it, but this shows us that we've actually passed in a bullet, and here's its transform information. Just very poorly rendered out using IMGUI. Like, this all looks like garbage, but there it is. Okay, so we can iterate through all that information. Now what will be nice for later on is to actually be able to group component data on a per entity basis for debug viewing, rather than iterate through and like, here's all the transforms, iterate through, here's all the sprite components, here's all the rigid body components, right? Instead, we can, for this purpose, be able to say, for this particular entity, give me this component data, which I think we can do. So we use this iterator. Can we use the same iterator? How to use the debugger, VC debugger? Yeah, so if I ever want to debug, then I'll just call dev environment on the executable. And then that launches up an instance of Visual Studio with the executable, as long as it has debug information, which I think right now I'm compiling with debug information. Yeah, so I'm compiling debug right now, so it has all the PDB information that Visual Studio needs. And then I just use it then. Otherwise, I just stay in here, and a lot of the time, I mean, I'll just throw down print statements. But also, some of the stuff you need visual debugging, right? So that's why I'm using IMGUI, because you need to see the data behaving in real time, and sometimes stepping through a debugger actually isn't the most useful way to do that. So this would be useful. So I'm gonna try to think about a way to do that. For now, again, we're validating that we actually are pushing back a single bullet. And yeah, so now what we can do actually, for the update, maybe we want to pass back I also use print statements. It just feels very web dev like. I can understand that. I think you get to a certain point where just dropping print statements isn't useful, but if I just need to visualize what the data is doing, it's fast enough for me to drop a print statement and then just see it change over time, which actually that's useful, by the way. So you're doing something. This is again why I said using a visual debugger in the form of something like IMGUI is actually useful, right? So if I'm interested in the player's transform position and what it's doing as I'm moving around, me stepping through this in the debugger actually won't work. I need to see it changing in real time, right? To see whether or not this information visually makes sense as it's changing in real time. And effectively, this is the same as a print statement. I'm just not dropping print statements, right? But I'm still dumping that information out to something I can visually see changing in real time. So I wouldn't feel hacky about it. I think it's definitely a valid way to do things. I think people listen to university professors way too much. I'll say that. I'm gonna grab more coffee real quick. What if your professor is Harold Abelson? Okay, sure. You can listen then. But only if you actually believe what he's saying. So let's actually draw the bullet to the screen. Let's see if we can get it drawn. So for now, I'll just dump it into one of these other quad batches. This is all going to get cleaned up. All this is just kind of out in the open. Well, some of the background stuff, we can probably just dump that into something else, like a different file, so it's just out of the way, but it might stay the same. Let me close some of this stuff out. So I think we will add it just to here. So we have our bullet group, entity group of bullets. That's our context dot entities dot bullets. How can I copy your Sublime theme? I don't even know what I'm using. I think I'm using material. Yeah, so just go into the package manager and install the material theme, and I just use the dark theme. And then, yeah, I think that's it. So grab our bullets and, man, maybe we want to hold on to entity handles. I don't know. because I want to be able to grab, for a given entity, I want to know its transform. How am I going to do this? Huh. Because I do want to know. Oh, yeah, I have handles. So why am I caching handles if I'm not going to use it? So let's just do this. We're being dumb here. So let's say for the entity group, so we have all of this stuff, but then we'll also have just handles into the entities themselves. Let's just do that. Why not? Okay. And then whenever we go to cache this, let's pass the handle. Get rid of that. And then down here, we'll just iterate through those handles. So we're going to iterate through every single entity, and we're going to grab the component for each of those. When do you start working on your full-time job? Here in a little bit, actually. So it's still kind of early in the morning for me. But I usually do this for like my lunch break and then just work through. Okay, so we're going to iterate through our bullet entities, and let's see. And this might not be the way to do this, actually. We might actually hold actual entity IDs. Well, I don't know, man. I don't know how we're gonna do this. So we can look at entity handles. Let's just call it entities. Fuck it. Okay, so that's good. We're iterating through those. All right. So we grab those, we have the sprite component, and now we should be able to define this. I think you're the only person that's ever purchased a license. Congratulations. Let's see. So we have our, let's just pass. We have our UV. So our sprite UV. Oh, we actually don't even need to store the atlas, because this atlas is stored in the material for the quad batch that we're using here. It's in the background element, so we kind of know that. I don't know if this is necessary, so we'll probably get rid of that here in a second. We have our camera transform with this. We're gonna abstract this out. I can already see it. The scale factor is the player scale factor. That should be stored up here. Yep. Okay. I think that's it. So, shut up, Sandboxy. So the origin. There's no I here. We're not moving it with the camera. We just care about the origin. Origin.y plus TO. What's this going on here? We might just want to set this to just that. UV color. Okay, I just want to see what this gives us. All right, there we go. So you guys can see we have a bullet being drawn there. Okay. Let's have some fun. So let's update our bullet entities. What am I looking for? Okay, so here's our update. Just so much for a bullet. Yeah. But it's really not that much. I'm gonna do all this for a new architecture. Yeah. You were not wrong. So let's grab the platform. And then we'll grab, why do I care about the platform? Just don't necessarily care about that. Okay. Let's have a bullet. The bullets that we have. Let's iterate over the entities. So we'll do the exact same thing that we did a second ago. Right, okay. So we'll grab the transform component. I believe that is, yep. Slot array get pointer, is that correct? Yep. Okay, so all we're gonna do now is we're just gonna grab the transform for each bullet that's in our entity array, and we're just gonna move it. Just a random movement. Okay, and then what we could do, let's just do a sign pattern. So, or a circle pattern. So 32x to 32y. So our x will be the cosine of t, sine will be sine of t. This will give us a -1 to 1 range, and then we'll multiply this by a radius. And let's just do a radius of, let's do 2. Although that might go off the screen, we'll see. Because our scale is kind of out of whack. And we also want to offset this by, maybe not times I, just plus I. So that way our time gets offset by the actual bullet index. We'll set the position, and that should be good. And actually what we could do is binary size. Okay. This will all make sense whenever you see it. And again, let's go ahead and let's just iterate by static value. What collision detection system will you implement for bullets? It'll be the same thing. So they'll follow axis line bounding box. I mean, we could do circle, so that's fine. Actually, that might be what we do, is just do a circle versus rect. Simple to do. So we're gonna get the total size of all our entities. We're gonna define a step size. And if there aren't any entities, then we're just gonna set that to 1, because we're not gonna iterate through this. That's just to keep us from doing a divide by 0. We're gonna grab the transform components. We're gonna set our radius to 2. This is gonna be our time for that given bullet. And again, it's gonna be our starting time that we're at. And we're gonna bias it and offset it by the index times the step. So that'll give us a normalized value for the circle. And then we're gonna set our position to that. Okay, this should compile. Don't see any reason why it shouldn't. What did I miss? I probably have this up here. No, it's good. What am I missing? Position is not a member of transform component. You're still upset about this for some reason. What? What? What am I missing? What are you complaining about? Okay, so there's something in here that's being strange. Yeah, I don't like this. Oh, because I'm not passing an ID. That should be good. Yep. Okay. Okay. And now when we update this, we will update player update. Let's update game context. Okay. And then for this, we're just going to update. I need to group updates. Alright, so what I expect to see is this bullet not doing that. Oh, I'm not. Duh. There we go. Alright, so now we're updating our bullet. The one bullet that we have, right? So now it's just over time doing a circular pattern. So now if we go to let's just do, do I have the platform here? I do. Let's say, let's just do this. So if we go to platform, we actually have a mouse pressed. And then if we go here, mouse L button. So if we click, then we'll add a bullet. Okay, so let's go back to add bullet. And again, we don't need this atlas. I'm not doing this. Don't need it. Don't need to set that. Damn it. We might need it later on, but for now I don't care. Alright. So now should be able to add more. Yeah, there we go. And the offset's not working quite the way that I thought it would. Okay. It's not working quite the way I thought it would. wonder what point it's going to start affecting frame rate. Yeah, let's check it out. How many you want? Let's do 100. So there's 100 bullets. There's 1,000. Like I'm still going okay. Actually, we can go into the debug UI and start printing out our frame rate. Fill your RAM. Yeah. Your VRAM. Oh, the VRAM, I mean, it's not going to be really affected that much. Because I'm using a quad batch, so. 1024 by 4. Let's print out our frame rate. So debug info. Which this is. Let me look at platform. Time dot frame. So we're hitting 16 millisecond. We're good. So we're locked to 16 milliseconds right now. Which we're in good shape. So actually in our initialization for the app, we could set the frame rate here. So we can set it to 30. Now we're at 33 milliseconds roughly. So that's all controllable in the engine, by the way, or the framework. Let's set that back. I think it'll lock to 60. Oh no, there we go. So now we're 120 hertz. Now it's noticeable. No, I set that manually. Like I said, down in this frame rate, I can set whatever frame rate I want this app to run at. So I can set it to run at 10 hertz if I want. So now we're running at a rate of 10 hertz for the application. So this updates the internal clock. It'll be limited by however fast the application can run. So if I set it to something ridiculous, it might not be able to hit it. Oh, there we go. It can run at 4 milliseconds. So that runs just fine. Well, what about 500 hertz? Will it run at that? Probably not. Yeah, it will. Okay. I don't know if we'll hit 1,000 hertz. No. So it looks like we're CPU bound at least, or maybe even GPU bound to about 500 hertz. But there's nothing going on, right? So it's not CPU bound. CPU is barely doing anything. The GPU is barely doing anything because again, it's one draw call. I'm dumping all of this into a single draw call. So I'm not, hitting the GPU for each of these things being drawn. They're all being drawn to a single batch. And then that vertex data is being pushed to the GPU in one call. So, all right, so that's fun, but let's just lock it back to 60 hertz. I'm not sure, what did the SNES run? What did SNES refresh rate? Yeah, it looks like the SNES ran at a 60 hertz for refresh rate, so. Would love to see the inner workings of Gunslinger. Yeah, I've thought about making a video. That's kind of what this series was trying to do, was as I'm streaming and working on stuff, you guys can kind of see what this framework is possible of doing. And yeah. But, you know, it would be cool to do like a really, really, really simple example and then go through the basics that way and just work through starting from the most basic application to something a little more complicated. Yeah. But yeah, thanks. So we have what about 10,000 bullets? I don't think that'll do much. Nope, still hitting 16 milliseconds. It feels so slow now that we were running at 500 hertz, 100,000. So adding all these is going to take time. So that's one thing. So an initial dump of 100,000 is going to take time. So maybe not that. But if we did something like 25,000, maybe a small dump and then it'll jump in. Okay, so 25,000, we're starting to see a little bit of a slowdown. But again, I'm also streaming. I've got Chrome open, which, you know, I guarantee if I stop streaming, this will jump up. But I also don't anticipate having to have 25,000 bullets going. So let's drop that back down, really to nothing, because we're not doing this. Let's actually start to add this so that for the update we won't be doing this. This is just a fun test. What we are going to do though is iterate through the components, and so we need to move bullets and then collide. So how are we going to handle that? How are we going to handle this, chat? Because what we need to do is be able to have all the collision information for other entities as well. So this could be an interesting dilemma. What time is it? Okay, I'm gonna have to go here pretty soon. But we know we're not doing this. So let's cut this out. Cut this out. Don't need that. Don't need that. Okay, so we can get the rigid body component, we can get the transform component. Move transform by the velocity of the rigid body. So transforms position. We're going to add in the velocity, which actually normalize this, and then probably scale it. By 0.1. And whenever I add, so I do set its velocity, it's just going to move in the x direction. 451. Doesn't look like you're moving. Okay. I'm adding bullets as I'm doing this. So we're not actually updating by the velocity. Am I not calling update? What's going on here? Why is this not getting hit? I'm updating. Okay. Okay, so we are jumping into that, but we're not getting into here. All right, there we go. We have a 0 velocity. All right. 0 velocity. Why? Maybe because when I'm adding, I'm not setting the velocity. Yep. Rigid body dot velocity equals data dot velocity. All right, there we go. And that zoomed past me. You probably couldn't even see that in chat or on the screen. So let's do a slow speed. Okay, so there goes our bullet. Okay, so now we're firing, they're updating over time, moving in velocity. Okay, cool. Stop dropping that, that's gonna slow things down. So a couple things we can do here in the future, we'll check to see if it goes off screen. If it does, we'll kill it. If it collides with something in the level, we'll kill it. Yep. So that means that our entity group is going to have to be able to have game data, which is going to be interesting. Because we have to be able to know like world data that we need to be able to collide with. So we want to know if you collide with entities, we want to know if you collide with world, anything in the world, like stuff you can actually shoot, we have to know that. So this might actually get nasty. So maybe there is a reason and like usefulness to some of these rigid bodies being just in a generic dynamic world. know. Also, I think this speed is pretty good actually. It's not bad. Now what we can do is whenever we actually add a bullet, what's your FPS? I see 16 milliseconds, not sure what it converts to. Yeah, so take whatever, if you open up a calculator, I don't use FPS because it's not a good marker for actual frame rate. If you take 1,000 frames and you divide it by whatever the milliseconds for the frame time is, that'll give you rough FPS. So we're hitting, you know, roughly 60 frames. But I don't like FPS because it gives you a false sense of what your frame time is actually doing, especially if you're dropping frames, right? So if you're in industry, for instance, and you have, if you have a budget, let's say you're on the engine team, more specifically, if you're on the graphics team, right, and you have a budget of your frame rate has to hit. This is how it works in industry. You have a budget, you have a frame rate that has to hit. Let's say you're on Xbox One and your frame rate was 33 milliseconds, right? Which is what a lot of Gen 1 games that came onto the Xbox One had to hit. That tends to be the case for a lot of consoles, by the way. Whenever they come out, they're pushing the tech so hard for their flagship games that they kind of have to lock their frame rate to 33 milliseconds because a lot of the shit that they're trying to do, they can't hit in 16 milliseconds. So you have a budget on the engine team, it's 33 milliseconds, and you, on a particular team, you're given like a subset of that budget. Like, hey, you're on the graphics team, you get, you know, 7 to 8 milliseconds a frame. Literally, this actually does happen in industry for certain teams. It's like you get this much. If you get over that, then we're in trouble. So, and you got to refigure it, you know, figure out what you're doing. If you're talking about FPS, you don't really have a good indication of a drop in frame time, right? So if you're talking 200 frames per second and you drop down to, let's say, 100 frames per second, right? Because it's an inverse, you don't get a good understanding of what that is, right? So 200 frames, let's see, what's the way to think about this? So 200 frames times, let's see, 1,000 divided by 16.67. So that gives you that. And if you drop, let's say you're at 16 milliseconds and you drop down a millisecond, right? So you go down to 15. Now, if you take 1,000 and you divide it by 15 milliseconds, right? I'm sorry, I went the other way. You take 1,000 milliseconds and you divide it by, let's say, 17. So now you've only dropped 2 FPS, but you've actually fallen a single millisecond, which is quite a bit. Now, let's say that that's a 1 millisecond difference, right? In actual physical measurable time, right? Because FPS is not a measurable unit of time. So you drop down 2 FPS, but you actually drop down a full millisecond in your frame time. So let's say that you were at 33 milliseconds and that's your budget for the entire thing, right? And you drop down a full millisecond underneath that, right? So you do 33 milliseconds, you're able to shave off a millisecond. So you're now able to go down to 32 milliseconds. You've just increased the budget for an entire team, right? So that millisecond you shaved off of your 8 milliseconds of budget, maybe you can allocate that to another team that could use it, right? If AI is taking up a millisecond or two more than it should to hit that budget and graphics is running a millisecond above what it should, you can allocate that towards AI, right? But let's say in 33, if we look at this at what it looks like in FPS, you go from 1,000, so that's 30 frames a second, right? let's say you actually shaved it off, and now instead of 33 milliseconds, you were at 32, right? So you get kind of a little bit of a jump, but it's not that much, right? But let's say like, geez, what's a better example of this to really illustrate like the huge jump that you get? Like when I was jumping from the difference between 200 milliseconds and 200 frames to 500 frames is not that much, right? That's a 300 frame difference. But if I do 1,000 by 500 frames, that's just 2. Actually, it's 1,000 by like 4 milliseconds is 250. But if I do 1,000 by 3 milliseconds, that's a difference of 133 frames, right? But it's just, that's not a good marker. So I've only jumped 1 millisecond in that range, but now I've got a range of 133 frames. So it's just not, it's not linear. It's not a linear, because it's an inverse. It's not a linear handling of the time, right? Hopefully that makes sense. I think I did a really shit job of explaining that. Basically, it's the higher you are in terms of milliseconds, and you start shaving that off, you're going to get lower returns in terms of what your frame per second is. But the lower you are, you're going to get higher returns. So if you're running at 4 milliseconds and you shave it down to 3, that's a huge frame bump. But it's really just a millisecond in time. It's not. Anyway, sorry for the shit explanation. So measuring time per code part, measuring, well, like I said, the FPS, it's an inverse measurement, so you're not getting an accurate representation of what's actually going on. If you shave off a millisecond, that's good, regardless of whether or not it was from, like I said, going from 500 frames per second to 200 frames per second, or 333 frames per second, right? So engine devs will always use milliseconds as their timing, because it's just more accurate, or at least it's not necessarily accurate. It's not an inverse calculation, so it gives you a more accurate representation of what's actually going on. Anyway, got the UVs. Where are we at again? I'm about to leave here soon. Yeah, so we're doing this. Okay, so whenever we push this back, let's just push it to the player. So we're actually adding a bullet. So the position will be, let's say, I don't think that's right. Cool. Awesome, Dirty Mint, I'm glad. I don't, let's, bullet data, let's make this a V3, make this a V at, now when I shoot, it should start at the player. Okay. So that works. Okay. But we have the player's heading, so we could do that too. So GS back to scale. So now we're just scaling the velocity by the player's heading. So as we fire, it's going to go the direction that the player is actually facing. But it's coming out of his crotch, so that's one thing we'll have to change. So all we'll have to do for that is we'll just add an offset, which is going to get kind of gnarly, so we'll declare this. And it's going to be based on the player heading as well as our scalar. Oh, not really. Not really. Because we don't want to affect the Y. So we'll just do this. Okay, so we're going to multiply some amount by the player heading, which I think we can go, I don't know, 2, just some offset. We're going to be biasing this just to see. This is just so we make it come out of the gun and not his nether regions. So the position should be, we're going to add the offset to the player's position. What's the problem here? Oh. Let's make it 3. What? No. How the hell do I do that? Move it over a little bit more. So let's just do like a full unit. Not that much. I'm just playing with numbers here. That actually looks okay. And again, we don't have to, I'm doing mouse press, we can actually do mouse down. So this is gonna get kind of crazy. So we'll see how well this handles. Yeah, here we go, machine gun fire. And there you go, there's my, there's the parabolic jump. I can't remember, in Contra, could you fire and jump at the same time? I think you could, right? So we'll probably keep that. Anyway, by the way, I'm just sitting here. These bullets are never getting cleaned up, so I've just been holding it down. We're running still at 16 milliseconds, so I don't even know how many I've got going. But yeah, it's dumping one out every frame that I have down. So did you rip the assets from the original game? Yeah, just textures I found, and then there's various ways that you can rip assets from like emulators and stuff. So, and then Photoshop work, actually I did some painting, just changing some assets. So this is actually going to be, we won't do this obviously. This is going to be in the player input, and it'll be based on how much you can shoot in a frame. Because right now this is kind of goofy. This actually might be a little closer, might look a little nicer. Yeah, that looks, I'm happy with that, chat. I think that looks pretty good. So we can also do, based on the player state, how we're gonna affect where these rounds are going. So the velocity is not this, right? So how do I want to do this? The bullet velocity is I don't even know what I want to call this. And we're actually making it back 3. Because all we're going to do is just switch on the player state. Okay, and then we can just return what we want. I don't necessarily care about. Okay, so if we are running, our gun is forward, we're not firing. Let's see. For not firing, I don't care. If we're not firing, I don't care. Actually, okay. For now, we'll just do this. Running, gun forward, then it's going to be 1, 0, 0. If the gun is down, 1, let's call it 1. If we're jumping, we'll just do 1. Okay, I have no idea if this is going to be correct. But we're going to check it out. So we're going to scale, instead of this doing this right vector, we're actually going to scale this. Oh shit, I do want to. Okay, so well, that's good. So for some reason they all have a 0 velocity, which doesn't make sense. Huh. Why are you giving me a 0 velocity? Why are you doing that? Yeah, it's still 0. Huh, okay. Oh, why am I doing doubles? What the hell? Okay, alright, so that's right, but I'm gonna have to change the offset. Oh, okay, weird. So oh, that's interesting. I actually don't even have a running gun up. So that's odd. Am I changing the heading? That's probably why, because I'm multiplying the heading. Velocity scale. Yeah, I don't want to scale the whole thing. So just the X. Ah, damn it. All right. Okay. Okay, so those need to be swapped. So gun down. -1, +1, +1. Okay, so the offsets are wrong, obviously, but we'll have to define pivot points for where these go, but you know. So we'll define pivot points for where these actually start, depending on where the gun is. That'll be easy enough to do. We could do lifetime for the bullets, but really we don't have to do lifetime. We'll just do if it goes off screen. Then we'll look for that. Cool. Okay. I think it's probably good enough for today. And so what we'll do tomorrow is start defining these pivot points. Then we'll start having these bullets actually interact with the world. So we'll grab collision data and do that. And then someone mentioned quad trees. Yeah, at some point we're gonna have to have some kind of spatial partitioning, so we're not trying to have everything collide with everything else. So we'll probably have to do something like that. And then, yeah. Cool. GL Dev, good stream. Yeah, thanks. H, wow, it looks great. Yeah, thanks. Thanks, man. It's getting there. It's definitely come a bit of way since we first started, right? So we'll get it there. It just takes time. And again, when you're only doing it like an hour and a half a day or something, it takes a little longer than you'd want. But so I'm gonna end it here, but I'll hang around for a second if anyone has any comments. Kind of do Q&A if anyone has anything they want to ask. If not, then I'm gonna hop on out. Here's all the bullets, by the way. Just dumping them into here. Yeah, sorry, man. I've been going for a bit though. But if you want to catch back up, it'll be posted so you can rewatch it. We went through the entire entity component stream or component system and made our entity groups and made our bullets and yeah. Why does your stream have comments from 3 months ago? I don't know. All right. All right, guys. I will talk to y'all later. Thanks for dropping in. If you're not subscribed, please be sure to do so. Also, like the stream, share it, do all that stuff. Help me shill. Someone who's not a good salesman, help me shill. Yeah. All right, guys. Bye.